So, good morning, guys. Good morning. Good morning. Yeah. So, welcome to NEET World Institute and NEET World YouTube channel. So, yes. So, we are meeting after long back, right? Like 3-4 days, right? So, today's class we are going to concentrate on this very short answer questions, which is in class 11th IPE physics. Okay, very short answer questions. Remember that, very short answer questions, VSAQs. Okay, so the lesson name is laws of motion, and the next lesson we are going to see work, energy, power. Like we are going to concentrate on the two lessons, laws of motion and work, energy and power. Okay, fine. So let's go into the topic first. So first question of this laws of motion is, what is inertia and what gives the measure of inertia? First of all, we need to understand the meaning of what is inertia. Okay, so two questions they have asked, like first part is what is inertia and second part is measure of inertia, how we will measure that inertia. Okay, so inertia is nothing but it is inability of a body change its state of rest or uniform motion. Remember that, state of rest or uniform motion in a straight line in the absence of the unbalanced external force is called as inertia. So inertia is nothing but it is inability of a body to change its state of rest or motion, uniform motion. Okay, it's not a motion, uniform motion in a straight line in absence of the unbalanced external force is called inertia. So how we will measure that inertia? We will measure inertia in terms of mass. So mass of a body is the measurement of inertia. So remember, when mass is more, like more mass, inertia also more. So when more mass, inertia also more, mass is less, inertia also less. Okay, that's the point we can understand from this first question. Got it? So first question, what they are asking, what is inertia and how we will measure that inertia. So inertia, it's nothing but inability of a body to change its state of rest or uniform motion in a straight line in the absence of the unbalanced external force, and we will measure in terms of mass. Okay, got it? So this is the first question. And when we go for the second question, right, when a bullet is fired from a gun, the gun gives a kick backward direction. Why? That is the question. Explain it. So when a gun is there, when we shoot, like it kickbacks, like bullet is going front and the gun kickbacks, right? No, so why it happens? What is the reason behind that? Okay, so when a bullet is fired from a gun, the gun gives a backward kick due to the opposite reaction force. So where we have studied this opposite reaction force? Yes, this is in accordance with the law of conservation of linear momentum. Okay, this is where we have studied the like opposite reaction force, like equal and opposite force, like Newton's third law we have studied, right? Yes, so when a bullet is fired from a gun, the gun gives a backward kick due to the opposite reaction force, and this is in accordance with the law of conservation of linear momentum. Got it? Right? Yeah, you can take a note of this first two questions and we can go for the next questions. Okay? Yes. Done? Yes. So the next question is, if a bomb at a rest explodes into two pieces, the piece must travel in opposite direction. Why? What is the reason behind that? And explain that. Okay, so this is the third question, right? So yeah, so bomb initially at rest, which means initial momentum also will be rest. What is momentum? Momentum is nothing but mass into velocity. Momentum is nothing but mass into velocity, which is denoted by the letter P, right? P, right? Yes. So if it explodes into two pieces of mass m1 and m2, move with velocities v1 and v2. If like initially it is at rest, u is equals to 0, but mass will not be 0, right? Mass will not be 0. Since u is 0, momentum also will become 0. Mass into velocity 0, so total will be 0. After exploding, it went into two things like m1 v1, m2 v2, right? So then according to law of conservation of linear momentum, initially like the total mass was like m1 plus m2 I have taken as m, right? And velocity we have taken as 0. So how we can mention initial? P initial will be equals to mass we have taken, that is mass, and velocity we have taken 0. Then P final will be equals to m1 v1 plus m2 v2, right? Now, so we know that initially and final, like initial and final momentum will be same. P initial will be equals to P final. So P initial was 0. What about P final? It is m1 v1 plus m2 v2. We have got that, no? So from this we can take that m1 v1 will be equals to minus m2 v2. So since v1 and v2 are opposite, the two pieces must travel in opposite direction. v1 v2 and this negative symbol gives that opposite direction. That's why it travels in opposite direction. Got it? Okay. So the next question is, yeah, why does the car with a flattened tire stops sooner than the one with the inflated tires? Okay, so a flattened tire has more area of contact between the surface, which means when a flattened tire is there, no, like area of contact will between the surface will be more. Okay, hence rolling friction increases and thereby a car with flattened tire stops sooner, because only one reason, area of contact between the surface and the tire is more. Okay, that's why it getting stopper soon. Okay, now fifth question, arcs as a exert a greater force during the start of a motion than a later. Why? Explain. So initially a cart has to be overcome the limiting friction. So I'll explain what is that, what's happening in there. Okay, so like if you take that surface, no, like a wheel will be there, cart, and arcs is there. Okay, arcs is there. So I need to overcome the limiting friction, like the friction is there. Initially it is rest. Initially it is at rest. Now what happens? I need to apply more force to overcome this friction, right? Like obviously the friction force is acting over here. Friction force means an opposite direction. So in which direction I should give a force to overcome? Yes, I should apply the force in this direction. How much force I need to apply? Like I need to apply a more force than the friction force, like limiting friction force. So we need to apply more force than limiting friction force. Right now, limiting friction force, that's the thing we need to do over here. That's initially the cart has to overcome the limiting friction. Once motion has started, no, the frictional force reduces. Obviously the friction force reduces, and hence arcs has to pull the cart harder during the start. Not only the arcs, like whatever the objects present over there, initially they need more force than the limiting friction force to pull the cart, right? So this is the fourth question says. And what about the next question? I mean, see, fifth question says, what about the next question? A car, can the coefficient of friction be greater than 1? Okay, yes, in general, no, like coefficient of friction is less than 1. When the surface is heavily polished, the frictional force increases due to the increase in interatomic forces. Okay, interatomic forces. In such a case, coefficient of friction will be greater than 1. So when the surface are heavily polished, adhesive force increases. Okay, clearly understand the thing. In general, coefficient of friction is less than 1 in general. Okay, but when the surface is heavily polished, the frictional force increases due to the increase of interatomic forces. Okay, in such a case, coefficient of friction will be greater than 1. So when the surface are heavily polished, no, adhesive force increases. Okay, got it? Now, seventh question: what happened to the coefficient of friction if weight of a body is doubled? What will happen to the coefficient of friction? So coefficient of friction, right, it is independent, right? So coefficient of friction is independent of mass of a body, hence it remains same. Independent, no, like only coefficient of friction we are talking, right? We are talking about this part. So it is independent of mass. So it remains same. Got it? So this is about the laws of motion, VSAQs, right? Once you can now take a note of this, and we can go for the next lesson, right? Done. Completed. Okay, so the next one is work, energy and power, right? So first question of that work, energy, power. So state the sign of work done by the force in following. Listen carefully. They have asked, state the work done, like sign of work done by the force in the following. So following in the sense they have given some questions, right? So first question: work done by an applied force. Okay, listen. Let me take a pen. Wait a minute. Yeah. So first question number 1, question number 2 they have given. Okay, work done by an applied force on a body moving on a rough horizontal plane with uniform velocity. Work done by an applied force on a body moving on a rough horizontal surface. Okay, horizontal surface plane with a uniform velocity. Next question, what they are asking: work done by the resistive force of air. Resistive force of air on vibrating pendulum in bringing it to rest. Okay, two questions and two different things, like one is rough surface and one is a resistive force they have given. Okay, but when we see here, work done by an applied force on a body moving on a rough horizontal plane with uniform velocity will be positive. But when I talk about a resistive force, obviously it is a negative force, it's opposing force, right? So work done by the resistive force on air on a vibrating pendulum in bringing it to rest. So when object is going with some velocity, like for example 10 meter per second, I need to come to rest, which means I'm reducing 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. I'm reducing it, no? So for reducing, what I should do? I should like subtract it, minus 1, which means I'm using the negative. But work done by applied force on a moving body on a rough horizontal plane with a uniform velocity. See that word, you should understand: uniform velocity and resistive force. So by using this words, now we can able to identify which sign we can use over there. Okay, this is about the first question of that VSAQ of work, energy and power, right? So the next question is, a machine gun fires 360 bullets. Okay, 360 bullets more. Like now we can able to remember that KGF right now. So Yash is using that machine gun to fire that whole police station, right? Yeah. Okay. Yes. Okay. Apart. Okay. We'll start here. So a machine gun fires 360 bullets per minute. More per minute, and each bullet travels with a velocity of 600 meter per second. Okay, so if a mass of a bullet is 5 gram, mass of a bullet is 5 gram, find the power of a machine gun. Okay, see here, listen, power is nothing but it is work done by time, right? Work done by time. We'll keep as it is, this power, and now we should identify what is the velocity, I mean what, like how much bullet it will take per second. They have given per minute, we need per second. Per second in the sense 1 minute 60 seconds, right? So 1 second in the sense 1 by 60, right? 1 minute by 60, got it? So what we should do here, 360 divided by 60, which gives 0 0, and this is 6 times, so 6 bullets per second. N is nothing but 6 bullets per second. We know that is 600 meter per second. So 600 meter per second, this is given, guys. It's a given terms only. We are not going to get anything from the KGF movie and all. Okay, that's a given question. Okay, and mass is 5 gram they have given. No, so 5 gram in the sense I need to convert into kg, which is the SI unit, right? So what I should do, so 1 kg is nothing but 1000 gram, right? No, so I need to convert into kg, like, which is nothing but 10 power minus 3, right? 10 power minus 3, so 5 into 10 power minus 3. And power, as I told, power is nothing but work done by time. So what is the work done here? It is a moving thing, now, like it's having a velocity, it's having a mass, which is nothing but I can use kinetic energy of mv square, and how much bullet they are saying, like 6 bullets per second, n divided by time is given, right? No, time is given, right? 600 meter per second, and per minute. Okay, per minute, we are taking per second, that's it, t, got it? That's it now. So how much? Half into velocity, mass is 5 into 10 power minus 3 into this is a 600 square into 6. So that's it. Why we are not taking time? Because we know that it is 6 bullets per second, so I can take per second. Got it? N by t, 6 by t, that's it. Fine. Now calculate it. 1 by 2 into 5 into 10 power minus 3 into 6 36, and this 2 zeros will become 10 power 4. So 10 power 4, 2 zeros okay, into 6. So this is 10 power minus 3 and this is 10 power 3. Cancel it. So remaining how much? So this is 10, right? No, so once, and this is 5 times. So 5 into 36 into 6. Got it? 5 into 36 into 6. So how much we will get? Like around 540 into 10, which is something but 5400 watt, 5.4 kilowatt. Got it? Got it now? Understood? Okay. Done? Okay. So the next question. Pump is required to lift 600 kg of water per minute from a well of 25 meter deep and ejects with a speed of 50 meter per second. Got it? Calculate the power required to perform the above task. So pump how much, like required power they are asking? 600 kg, 25 meter with a speed 50 meter per second. So like mass they have given, right? 600 kg, right? So power is nothing but like, yes, I'll take. So when I talk about a power is nothing but work done by time. So we are taking the mass of that water, no, like from the bottom to the top, like obviously I'm using the height also and we are using that motion also, which means potential energy plus kinetic energy divided by the time will take, right? So what is potential energy? It is mass into gravity into height plus kinetic energy half mv square divided by the time. Got it? Per minute they have told. So for second we should take it 60 seconds. 1 minute equals to 60 seconds. So mass, like I can take the common thing outside. So I can take m commonly outside, gh plus v of v square divided by 60. So mass we know that is 600 kg. I can use directly 600 into g is 10 and the height is, how much height has been given? 25, right now? 25. Yeah, here they have taken 9.8. We'll take approximately and we'll get the answers. Okay, and write the thing approximately. Okay, that's the important thing. Plus 1 by 2. How much velocity? It is, velocity is, yes, 50 meter per second they have given, right? 50. Okay, we'll see that. Okay, and we'll get that half into 60 into 2500. Okay, 2500. So 50, no, 50 into 50 is nothing but 5 by 25 and this 2 zeros, right? So into 2500 divided by 60. 0 cancel and this 6 1 times and this is 10 times, right? So we will get the answer near to 15 kilowatt. 15 kilowatt. Got it? So this is the, yeah, once we'll see that velocity, how much they have given. Yes, 50 meter per second only. Got it? So this is the answer for this last question of the work, energy and power. Got it? So this work, energy and power, no, like they have not given the VSAQs in many things, like directly they have not given. But when we talk about the 8-mark questions, right, 8-mark questions, so with that attached problem will be there, no? So these are the attached problem, guys. These are the attached problem. Okay, so you can take a note of this carefully, because whenever we are writing this short, long answer questions, sometimes they will ask the attached question. So there the people will be stuck. Okay, so what I should do, what is this answer, like how I need to do that question. Okay, so this is how we will do with this. Okay, guys. So with this I'll conclude the class. Okay, so with this we'll go for the next lesson. Okay, system of particles and the mechanical properties of fluid in upcoming session. Okay, so thank you guys, we'll meet in the next class. Bye bye.